Hi dear students, welcome to my YouTube channel NJ Classroom. In this video we are going to learn what is an electric dipole. What is the definition of the electric dipole? The term associated with the electric dipole is called electric dipole moment, and the net electric field due to the electric dipole, particularly on the dipole axis, at any point on the dipole axis, at any point on the equatorial bisector, and at any point, generally at any point nearer to the electric dipole rather than the dipole axis or equatorial bisector. So myself Jagdish Narayan, teaching physics and mathematics. If you are not subscribed my channel yet, first subscribe my channel, watch the video completely. At the end, if you like the video, press the like button without fail. So after watching this video, definitely you will get some idea about the electric dipole, electric field due to the dipole. So let's go. What is an electric dipole? Dear students, first we have to come to the point of electric dipole. Already in previous classes we know what is a point charge. Let us consider plus q is a point charge. Plus q is a point charge. Dear students, ಈ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಫಸ್ಟ್ ಡೈಪೋಲ್ ಅಂದ್ರೆ ಏನು ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಒಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ತಗೋಣ. ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಪ್ಲಸ್ q ಚಾರ್ಜ್ ಇದೆ. ಇದಕ್ಕೆ ನಾವು ಐಸೋಲೇಟೆಡ್ ಚಾರ್ಜ್ ಅಥವಾ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ. ಕನ್ಸಿಡರ್ ಅನದರ್ ಚಾರ್ಜ್, ಓಕೆ, whose magnitude is same as that of the first one, that is q, but the nature is opposite. That minus q charge plus q charge ಗಿಂತ ಒಂದು ಸ್ವಲ್ಪ ದೂರದಲ್ಲಿದೆ. ಆ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ನಾವು 2a ಅಂತ ಕರಿತೇವೆ. ಆ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನು 2a ಅಂತ ಕರಿತೇವೆ. ನಾವು ದ ಸಿಸ್ಟಮ್ ಆಫ್ ಟೂ ಚಾರ್ಜಸ್. ಈ ಸಿಸ್ಟಮ್ ಒಳಗಡೆ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಇದೆ? 2 ಪಾಯಿಂಟ್ ಚಾರ್ಜಸ್ ಇದೆ. ಒಂದು ಪ್ಲಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಇದೆ, ಇನ್ನೊಂದು ಮೈನಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಇದೆ. ಈ ಪೇರ್ ಆಫ್ point two charges separated by a small distance is what is called as an electric dipole. Simply, what is an electric dipole? It is nothing but a pair of equal and opposite point charges separated by a distance of 2a. For example, consider another case. In another case, let us consider, we go for another case. Let us consider one point charge plus q and another point charge minus 2q. So now see here, even though the nature is opposite, ಇಲ್ಲಿ ಒಂದು plus q charge ಅನ್ನು consider ಮಾಡ್ಕೊಂಡಿದ್ದಾವೆ, ಇಲ್ಲಿ ಮೈನಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾವೆ. ಅವೆರಡರ ನಡುವೆ ಡಿಸ್ಟೆನ್ಸ್ 2a ಇದೆ ಅಂತಾನೆ ಅನ್ಕೋಣ. ಆದರೆ ಇಲ್ಲಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡು ಪ್ಲಸ್ ಕ್ಯೂ ಇದೆ, ಇಲ್ಲಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡು ಓಕೆ 2q ಇದೆ, ಇಲ್ಲಿ ಬರ ಕ್ಯೂ ಇದೆ, ಇಲ್ಲಿ 2q ಇದೆ. ಬಟ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ಸ್ ಏನಾಗಿದೆ? ಡಿಫ್ರೆಂಟ್ ಇದೆ. ಈವನ್ ದೋ ನೇಚರ್ ಇಸ್ ಡಿಫ್ರೆಂಟ್, ಸಪರೇಟೆಡ್ ಬೈ ಎ ಸ್ಮಾಲ್ ಡಿಸ್ಟೆನ್ಸ್, ಬಟ್ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ಸ್ ಆಫ್ ದ ಚಾರ್ಜಸ್ ಆರ್ ನಾಟ್ ಸೇಮ್. ಸೊ ದಿಸ್ ಈಸ್ ನಾಟ್ ಆನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್. ದಿಸ್ ಈಸ್ ನಾಟ್ ಆನ್ electric dipole. So in order to say electric dipole, the pair of charges must be equal and opposite. Look at here, that pair of charges must be equal and opposite. So now what is an electric dipole? There is a simple definition about the electric dipole, is that electric dipole is a pair of unequal and opposite point charges plus q and minus q separated by a small distance 2a. So now the line joining from positive charge to the negative charge, look at here, this is what is called as the line joining the plus q charge and minus q charge. That line is what is called as the dipole axis. That is called the axis of the dipole. Axis of the dipole is the line. Axis of the dipole ಅಂದ್ರೆ ಏನು? Axis of the dipole ಅನ್ನೋದು ಪ್ಲಸ್ q ಮತ್ತೆ ಮೈನಸ್ q ಚಾರ್ಜ್ ಅನ್ನು ಸೇರಿಸ್ತಕ್ಕಂಥ ಒಂದು ಇಮ್ಯಾಜಿನರಿ ಲೈನ್ ಆಗಿರುತ್ತೆ. The length of the dipole axis is equal to 2a. What is the length of the dipole axis? Is always equal to 2a. The midpoint of this dipole axis, that is called the center of the dipole, that divides the dipole equally from positive charge and the negative charge. This is what is a simple definition about the electric dipole. Let us go for the next one, is an electric dipole moment. The term associated with the electric dipole is called the electric dipole moment. The strength of the electric dipole moment, the strength of the electric dipole can be measured in terms of the strength of the electric dipole. Strength of the ಒಂದು dipole moment, ಒಂದು electric dipole strength ಎಷ್ಟಿದೆ ಅಂತ ನಾವು ತಿಳ್ಕೋಬೇಕಾದ್ರೆ ನಾವು electric dipole moment ಅನ್ನು ಮೆಷರ್ ಮಾಡ್ತೇವೆ. So what is the electric dipole moment? We know that this is what is called as a plus q charge. Let us consider this is what is called as the plus q charge and another point charge called minus q charge. Another point charge called minus q charge. The distance between them is equal to 2a. So now if you consider any one of the charge as q and the distance between the 2 point charges 2a, if you take the product, that is q into 2a, that gives the electric dipole moment. ಹೌ ಟು ಡಿಫೈನ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್. ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟನ್ನು ನೀವು ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಯಾವುದಾದ್ರೂ ಒಂದು ಚಾರ್ಜ್, ಡೈಪೋಲಲ್ಲಿರ್ತಕ್ಕಂಥ 2 ಪಾಯಿಂಟ್ ಚಾರ್ಜಸಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ದಿ ಚಾರ್ಜಸ್ಸನ್ನು ತೆಗೆದುಕೋಬೇಕು, ಮತ್ತು ಅವುಗಳ ನಡುವೆ ಚಾರ್ಜಸ್ ನಡುವೆ ಇರ್ತಕ್ಕಂಥ ಡಿಸ್ಟೆನ್ಸನ್ನು 2a ಅದಕ್ಕೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಆವಾಗ ನಮಗೆ ಏನು ಗೊತ್ತಾಗುತ್ತೆ, q into 2a is what is called as an electric dipole moment. So dipole moment of an electric dipole is the product of the one of the charge q and the distance of separation between the charges 2a along the axis of the dipole. Let us go for the first important thing is, already we know that what is the dipole moment. So very important thing is, dipole moment is a vector quantity. ರಿಮೆಂಬರ್, ದಟ್ ಇಸ್ ದಿ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್. ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಅನ್ನೋದು ಒಂದು ವೆಕ್ಟರ್ ಕ್ವಾಂಟಿಟಿ ಆಗಿರುತ್ತೆ, ಗೊತ್ತಾಯ್ತಲ್ಲ. ವೆಕ್ಟರ್ ಕ್ವಾಂಟಿಟಿ ಅಂದ ತಕ್ಷಣ ನಾವೇನು ಬರೀಬೇಕು, ಪಿ ಕ್ಯೂ ಅಂತ ಬರೀಬೇಕು. ಇದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ದ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್. ಪಿ ಈಸ್ ಈಕ್ವಲ್ ಟು, ಓಕೆ, ಜನರಲಿ ಇಟ್ ಈಸ್ ರೈಟ್ ಆಸ್ 2aq. ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ದ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 2aq. ಈ ರೀತಿ ನೀವು ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಅನ್ನು ಡಿಫೈನ್ ಮಾಡಬೇಕು. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಸೊ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ದಿ ವೆಕ್ಟರ್, ದ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ 2p vector is equal to 2aq into t cap. P vector is equal to 2aq into t cap. Remember, the dipole moment always acts. Remember the dipole moments. The dipole moments always acts from negative charge to the positive charge. This is the direction of the dipole moment. It is always acting from negative charge to the positive charge. Look at here. What is the direction? It is always acting from, the direction of the dipole moment is along the dipole axis from minus q charge to the plus q charge. So this is the formula for calculating the dipole moment in vector form. What is p cap? P cap is the unit vector. What is p cap? P cap is the, p cap ಅಂದ್ರೆ ಏನಪ್ಪ, ಅದು ಯೂನಿಟ್ ವೆಕ್ಟರ್ ಆಗಿರುತ್ತೆ. ವಾಟ್ ಇಸ್ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ದ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್? ಇಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 2aq. ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀವಿ ನೋಡಿ, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ದ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಎಷ್ಟಿರುತ್ತೆ, 2aq ಇರುತ್ತೆ. ಸೊ ಇದು ಒನ್ ಆಫ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್. ಲೆಟ್ ಅಸ್ ಗೋ ಫಾರ್ ದಿ SI ಯೂನಿಟ್. ವಾಟ್ ಈಸ್ ದಿ SI ಯೂನಿಟ್? SI ಯೂನಿಟ್ ಅನ್ನು ಹೇಗೆ ಬರೀತೇವೆ ನಾವು? ಇಟ್ ಈಸ್ ಚಾರ್ಜ್, ಇಟ್ ಇಸ್ ದಿ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದಿ ಚಾರ್ಜ್ ಇಂಟು ಡಿಸ್ಟೆನ್ಸ್. ಓಕೆ, ಡಿಸ್ಟೆನ್ಸ್ಗೆ ನಾವೇನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ, ಮೀಟರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ. ಚಾರ್ಜ್ಗೆ ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ, ಕೂಲಮ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ. ಮೀಟರ್ ಕೂಲಮ್ ಅಥವಾ ಕೂಲಮ್ ಮೀಟರ್ ಅಂತ ನಾವು SI ಯೂನಿಟ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಕೇಳಿದ್ರೆ ನೀವು ಬರಲಿಕ್ಕೆ ಗೊತ್ತಿರಬೇಕು. ಸೊ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಒನ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಈಸ್ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ. ವಾಟ್ ಈಸ್ ದಿ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ? Already we know how to write the dimensional formula in previous classes ಅಥವಾ in the first year ನಮಗೆ ಗೊತ್ತಿದೆ ಹೇಗೆ ನೀವು ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾನ ಬರಿಬೇಕು ಅಂತ. ಸೊ ಹೌ ಕ್ಯೂ ರೈಟ್ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ? ಸೊ ಲೆಂತ್ಗೆ ಓಕೆ, ವಾಟ್ ಇಸ್ ದಟ್ ಲೆಂತ್ಗೆ? L1 ಅಂತ ಬರಿತೇವೆ. ಓಕೆ, ಚಾರ್ಜ್ಗೆ AT, ಎ ಅಂದರೆ ಆಂಪಿಯರ್, ಟಿ ಅಂದರೆ ಟೈಮ್, AT. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಸಿಂಪಲ್ ಡೆಫಿನೇಷನ್, AT. ಓಕೆ, ರಿಮೆಂಬರ್, current is nothing but charge per time. Charge is equal to current into time. Current ge ampere, time ge t. That is AT is the dimensional formula. There is no mass up here. You can write it as m0. m0 L1 A1 T1 is the m0 L1 A1 T1 is the dipole moment dimensional formula. Dipole moment dimensional formula. Next we go calculating the electric field due to the electric dipole. Yes students, next we go for the electric field due to the electric dipole. So particularly at any point on the axis of the electric dipole, let us consider how to find the electric field at any point on the axis of the electric dipole. Let us consider, first we have go for the diagram. Consider this as a plus q charge. Let us consider this one as a plus q charge, and another charge is the minus q charge. Another charge is the minus q charge. This is the dipole axis. This is the center of the dipole. The length of the dipole axis is equal to 2a. Already we know it. Consider this is what is called as the axis of the dipole. This is the line along the passing through the, ಇಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ದಾವೆ, ಡೈಪೋಲ್ ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ನಾವು ಪಾಯಿಂಟ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೇಕು. Consider the point is here. Consider a point at a distance of r from the center. Center ಇಂದ r distance ಅಲ್ಲಿ ಪಾಯಿಂಟ್ P ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾವೆ. ಪಾಯಿಂಟ್ P ನಲ್ಲಿ ನಾವು ನೆಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಅನ್ನು ಕಂಡುಹಿಡಿಬೇಕು. ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಇದೆ? ಎರಡು ಚಾರ್ಜಸ್ ಇದೆ, 2 ಪಾಯಿಂಟ್ ಚಾರ್ಜಸ್ ಇದೆ, ಒಂದು ಪ್ಲಸ್ q ಚಾರ್ಜಸ್ ಇದೆ, ಇನ್ನೊಂದು ಮೈನಸ್ q ಚಾರ್ಜಸ್ ಇದೆ. ಇಂಡಿವಿಜುವಲಿ ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಪ್ಲಸ್ q ಚಾರ್ಜ್ ಅಟ್ ದ ಪಾಯಿಂಟ್ P and electric field due to minus q charge at the point P, later finding the net electric field at the point P, okay, by using the principle of the superposition. So at the point P, plus Q produces an electric field. Look at here, plus Q produces an electric field away from the point plus Q charges. Let us consider this one as the E plus Q. E plus Q is the electric field due to the positive charge, which is always away from the positive charge. So let us consider negative charge produces an electric field at the point P. Okay, but remember the magnitude is not same as that of the positive charge. But see the direction. The negative charge producing the electric field towards, that is E minus Q at the point P, acting towards the negative charge. So now we have to find out what is the E plus Q and what is the E minus Q. E plus Q is the electric field produced by the point charges plus Q. Okay, at P, let us go for the derivation. At P, electric field due to plus Q charge at a distance. What is the distance? At a distance of R minus A. Remember, this is very important. This is what is called as the distance from plus Q to minus, okay, point P. So totally R is the distance from the center, but we have to consider minus A. Illi navu ಏನು ಮಾಡಬೇಕು, A ನ subtract ಮಾಡಬೇಕು ಎಲ್ಲಿಂದ R ಇಂದ, ಆಗ ನಮಗೆ R minus A ಗೊತ್ತಾಗುತ್ತೆ. So what is that? The magnitude of that E plus Q magnitude. First we have to consider magnitude. Remember the dipole moment always acting from minus Q charge to the plus Q charge. This is what is called as the dipole moment P vector, always acting from minus Q charge to the plus Q charge. Okay, it is equal to, okay, remember what is the electric field due to a point charge? It is 1 by 4 pi epsilon naught Q divided by R minus A whole square. This is the electric field at the point due to the plus Q charge. Similarly, at P, what is the electric field? At P, electric field due to, what is that electric field? Electric field due to minus Q charge is, E minus Q vector magnitude. First we have to consider E vector magnitude, 1 by 4 pi epsilon naught Q divided by R plus A whole square. What is that? R plus A whole square. See here. So from negative charge we have to add A to the R, then only we get the total length from the negative charge to the point P where we are going to find the electric field. So now we go for the calculation. So first, okay, what is the total field? So at P, the net electric field is, what is the net electric field? E is equal to, magnitude of E is equal to E plus Q vector plus E minus Q vector. So remember, now look at E plus Q and minus Q. Both are acting in the opposite direction. What is the resultant of these two vectors? Electric field is a vector quantity. The resultant of the two vectors which is acting opposite in direction, we have to make them subtraction. So that is very simple. E vector is equal to 1 by 4 pi epsilon naught. E vector is equal to 1 by 4 pi epsilon naught Q by R minus A whole square minus of 1 by 4 pi epsilon naught Q by R plus A, okay, that is R plus A whole square. This is what is called as the magnitude of the difference between that into P cap. What is the P cap? P cap is the unit vector taking along the direction from negative charge to the positive charge. So therefore in vector form we are going to write this. This is the term related to the plus Q charge and this is the term related to the minus Q charge. So that is the difference. So therefore E vector is equal to, common thing is, what is the common thing is? Q by 4 pi epsilon naught is the common thing. So what remains inside the bracket? 1 by R minus A whole square plus 1 by R plus A whole square left inside the bracket. So into P cap, So now we go for the simplification further. So therefore E is equal to Q divided by 4 pi epsilon naught. Take the LCM. take the LCM. What is that? This is r minus a whole square into r plus a whole square. This is what is called as r plus a whole square minus r minus a whole square into p cap. Clear? Into p cap. Therefore, E is equal to Q divided by 4 pi epsilon naught. Q divided by 4 pi epsilon naught. Remember, r minus a whole square, r plus a whole square. R minus a into r plus a, that is r square minus a square into r square minus a square. We can write down like that. Denominatorly r minus a whole square na r minus a into r minus a anta barkobeku. Okay, idana r plus a na r plus a into r plus a anta barkondre 1 r minus a 1 r plus a is equal to r square minus a square using a square minus b square formula. What is a square minus b square formula? A plus b into a minus b. Very simple. So now expanding this one, r square plus a square plus 2ra. Okay, minus of r square minus of a square minus into minus plus 2ra by expanding the sign and using the brackets. Okay, so that is r square a square cancels into p cap. P cap remains. Very simple. So therefore, E vector, remember it is a net field, E vector is equal to Q divided by 4 pi epsilon naught. 4 pi epsilon naught. This is r square minus a square to the square. R square minus a square into r square minus a square. What happened? R square minus a square whole square in the denominator. In the numerator, it is equal to 4ra. Okay, into p cap. So it's a very simple derivation. So now in the next step, E vector is equal to, let us consider 1 by 4 pi epsilon naught as it is, 1 by 4 pi epsilon as it is, 2 into P, okay, that is Q, okay, one more thing is 4RA na ನಾವು 2 into 2A ಅಂತ ಮಾಡ್ಕೊಬೇಕು. So ಅವಾಗ ಏನಾಗುತ್ತೆ 2AQ into P cap, 2AQ into P cap, so into R divided by R square minus A square to the power square. So what you have did, it is 4RA, remember ಇಲ್ಲಿ 2 2s are 4RA, Q ಇದೆ, Q ತೆಗೆದುಕೊಂಡಿದ್ವಿ, P vector ತೆಗೆದುಕೊಂಡಿದ್ವಿ. But what is, okay, 2AQ into P cap, this is what is called as our electric dipole. What is that? That is the electric dipole. ಅದನ್ನು ನಾವೇನಂತ ಕರಿತೇವೆ? ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ therefore that is electric dipole moment. What is that? Electric dipole moment. So therefore E vector is equal to 1 by 4 pi epsilon naught, okay, into 2p vector divided by r square minus a square whole square into r. Let us consider an approximation. What is the approximation? Okay, if you consider the distance of the point r from the center is very large compared to the length of the dipole. That is, if r is greater than a square, r square minus a square whole square can be written as r to the power of 4. What happened? A square can be neglected in this formula. Okay, in this formula, a square can be neglected. A square can be neglected. So what happened here? A square can be neglected. Automatically, E vector is equal to 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, 2p vector into r divided by r to the power of 4. 1r cancel. So what is the final answer, dear students? The E vector is equal to, final answer is E vector is equal to, very simple, E vector is equal to 1 by 4 pi epsilon naught 2p vector divided by r cube. So now see the expression for electric field at any point on the axial line. So see here, what happened? The electric field is directly proportional to the, okay, strength of the dipole moment. That is, P E vector is directly proportional to the P P vector, that is called dipole moment, and electric field is inversely proportional to the cube of the distance of the point from the center of the dipole. This is what we are going to be concluded from this derivation. So at any point on the axis of the electric dipole, the strength of the electric field is always more. So next we go to electric field due to the electric dipole at any point on the equatorial bisector. Let us go for the electric field due to the electric dipole on the equatorial plane. So that is what is called, we are going to define the electric field due to an electric dipole at any point on the equatorial plane or equatorial bisector. So for that one, let us consider a plus q charge and minus q charge. This is what is called as the plus q charge, at a distance of 2a from the minus q charge. This is what is our electric dipole. The length of the electric dipole is equal to how much? 2a. ಎಷ್ಟಿದೆ ಲೆಂತ್ ಆಫ್ ದ ಡೈಪೋಲು? 2a ಯಾವಾಗಲೂ ಇದ್ದೇ ಇರುತ್ತೆ. ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ಯಾವ ಕಡೆಯಿಂದ ಯಾವ ಕಡೆಗೆ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇರುತ್ತೆ? ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಆಕ್ಟಿಂಗ್ ಫ್ರಮ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಟು ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. This is the center of the dipole. So now we have to write down, and dipole, remember this is what is called as the electric dipole. The center of the dipole, ಆ dipole ಅಲ್ಲಿ ನೀವೇನು ಮಾಡ್ತಾ ಇದ್ದೀರಾ? ಒಂದು perpendicular, equatorial bisector ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಬೇಕು. This is what is called as the equatorial bisector. At this point, consider a point P. This is what is equatorial bisector ಅಂತ imagine ಮಾಡ್ಕೊಳ್ಳಿ. At this point, so at the point P, at a distance r from the center of the dipole, plus q charge producing the electric field, and also minus q charge producing the electric. There are two fields are acting at the point P. Point P ನಲ್ಲಿ ಎಷ್ಟು electric field ಇರುತ್ತೆ? plus q charge ಇರುತ್ತೆ, ಇನ್ನೊಂದು minus q charge ಇರುತ್ತೆ. So point P ಇಂದ ನೀವು plus q charge ಗೆ ಒಂದು ಲೈನ್ ಅನ್ನು ಡ್ರಾ ಮಾಡಿ. This is the direction of the electric field acting. This is the direction of the electric field. This is what the electric field due to E plus Q acting in this direction. This is the direction of the electric field acting towards the minus q charge. This is what? E minus q. So see here, how many fields are acting? E plus q and E minus q. This is what is called as E minus q acting towards the negative charge. E minus q charge acting towards the negative charge. So now see here, what happened? Very simple. So E plus q is the electric field due to positive charge. E minus q is the electric field due to negative charge. Both are acting at the point P. So now draw an horizontal line. This is what is called as the horizontal line. So theta is the angle made by the line joining the point P with any one of the charges to the dipole axis. This is what is called as theta. Therefore, this is also equal to theta because of the corresponding angles are same. This is also equal to theta. Remember. So now divide or resolve E plus q and E minus q along the dipole axis and perpendicular to the dipole axis. So now we get two components. Remember, one component is equal to E plus q sin theta along the y axis. Let us consider this is what is called as the y axis, and one is equal to E plus q cos theta along the axis opposite to the dipole moment. Remember, this is the dipole axis and dipole moment direction. Similarly, E minus q along the dipole axis, E minus q cos theta, and along the negative y axis, E minus q sin theta. Look at along the direction of the y axis. E plus q sin theta acting in the positive y axis, E minus q acting in the negative y axis. Therefore, the net field in the y direction perpendicular along the perpendicular bisector is 0. Only field is acting along the dipole axis, in opposite to the length of the dipole axis. Using the principle of the vector addition, that is called vector addition, we can find out easily the net field due to the electric dipole at the point P. So now consider at P, electric field. One thing is E plus Q is equal to 1 by 4 pi epsilon naught. Q divided by square of the distance, positive charge. What is this distance? This distance, that is hypotenuse. Look at this triangle, right angle triangle. Look at this right angle triangle. This is equal to A. This is equal to R. What about this? This is R square plus A square root. That is square root of R square plus A square whole square. Whole square. So what happened here? So finally square and square root to cancel. E plus q vector is equal to 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught q divided by r square plus a square. Whole square root, what happened? Cancel. Okay, whole square and square root and cancel. So now and E minus q. So electric field due to E minus q vector is equal to similarly 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught again q divided by r square plus a square. Okay, r square plus a square into p cap. What is the p cap? P cap is the unit vector along the direction of the dipole axis. Remember equation, see these two equations, ಎರಡು equations ನೋಡಿದ್ರೆ ಏನು ಗೊತ್ತಾಗ್ತಾ ಇದೆ? ಎರಡು equations magnitude same ಇದೆ, but see the directions are different. The directions are different. Therefore finally the net field ಅನ್ನು ನೀವು ಕಂಡುಹಿಡಿಯಬೇಕು. ಹೇಗೆ net field ಅನ್ನು ಕಂಡುಹಿಡಿತೀರಾ? The net field at the point P is E is equal to finally E is equal to what is that? One thing is E plus Q. Okay, another thing is E minus Q. E plus Q and E minus Q. So in both the cases the common thing is cos theta. So see how we can find out the net field in the direction, okay, that is opposite to that of the electric vector. So therefore it is equal to minus P cap. So see the difference between these two. Electric field is always acting opposite to the direction of the dipole moment. Look at the diagram. Diagram anna nodi. This is the direction of the electric field is acting. Look at, this is the direction of the electric field is acting. But what is the direction of the dipole? The direction of the dipole is always acting from negative charge to the positive charge. But electric dipole and dipole moment are acting in opposite direction. Therefore we have considered the negative sign, dear students. Idanna ನೀವು okay ಹೆಚ್ಚು ಫೋಕಸ್ ಅನ್ನು ಮಾಡಬೇಕಾಗಿರತಕ್ಕಂಥದ್ದು. ಇಲ್ಲಿ at any point on the equatorial plane ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಯಾವಾಗಲೂ ಡೈಪೋಲ್ ಆಕ್ಸಿಸ್ ಗೆ ಆಪೋಸಿಟ್ ಆಗಿ ಅಪ್ಲೈ ಆಗ್ತಾ ಇರುತ್ತೆ. ಬಟ್ ಅಲಾಂಗ್ ದ ಡೈಪೋಲ್ ಆರ್ ಪ್ಯಾರಲಲ್ ಟು ದ ಡೈಪೋಲ್ ಆಕ್ಸಿಸ್ ಎಲ್ಲ ಇರುತ್ತೆ. ಬಟ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಗೆ ಏನಾಗಿರುತ್ತೆ? ನೆಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆಪೋಸಿಟ್ ಆಗಿರುತ್ತೆ. So now substitute E plus Q and E minus Q. E vector is equal to E plus Q, E minus Q, magnitudes are same. That is 1 by 4 pi epsilon naught Q divided by R square, okay, plus A square plus 1 by 4 pi epsilon naught Q by R square plus A square, okay, into cos theta into minus P cap. So now E vector is equal to 1 by 4 pi epsilon naught is common. Q plus Q, it is equal to 2Q. R square plus A square is also a common thing into cos theta. So remember, cos theta can be written as, look at this right angle triangle, dear students. So with the center to any one of the charge, either plus Q or minus Q. Cos theta is what? Adjacent by hypotenuse. Adjacent is equal to A. Hypotenuse is equal to R square plus A square. Square root means 1 by 2. Square root means 1 by 2 into minus P cap. So therefore E vector is equal to, final answer, E vector is equal to 1 by 4 pi epsilon naught 2AQ divided by R square plus A square 1 plus half into minus P cap. So therefore E vector is equal to 1 by 4 pi epsilon naught, it is equal to 2, okay, minus of 2AQ into P cap divided by R square plus A square to the power of 3 by 2. So 1 plus half is equal to 3 by 2. So now, but what is 2AQ? 2AQ into P cap, it is nothing but P vector. It is nothing but P vector. It is called dipole moment. It is very simple. So therefore E vector is equal to 1 by 4 pi epsilon naught. It is minus P cap. Okay, minus P vector. So minus P vector divided by R square plus A square to the power of 3 by 2. So now let us go for an approximation. What is that? If you consider the distance of the point R is very large compared to the half of the dipole axis length. So that is, if R is greater than A, what happened? R square plus A square to the power of 3 by 2. We neglect A square. We can neglect x square because of what? Compared to R, A is very small, A square is also too small. So neglect A square. So what happened? Neglect x square. So it becomes R square to the power of 3 by 2. Square and square root to cancel. It is equal to R cube only. So therefore final answer, our final expression for the electric field due to dipole is A is equal to 1 by 4 pi epsilon naught minus P vector divided by R cube. So remember why the negative sign appear in this equation. ಯಾಕೆ negative sign ಬರ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತು ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಅಪ್ಲೈ ಆಗ್ತಾ ಇರುತ್ತೆ. ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಅಪ್ಲೈ ಆಗ್ತಾ ಇರುತ್ತೆ. So now look at here. E vector is directly proportional to the strength of the electric dipole moment. If the dipole moment is very large, the field produced by the dipole is also very large, and also electric field is inversely proportional to the cube of the distance of the point from the center at any point on the equatorial bisector. So this is how we have to derive. ಈ ರೀತಿ ನೀವು with the diagram we have to derive. The diagram is must. You have to represent the diagram. Diagram is very must. Practice the diagram. The definitions will be very simple. So note that it is very clear. What we have note that the field due to the axial point and field due to the equatorial point is not same. So dear students, compare to the equations of that, okay, field due to the dipole and field due to the, what is the electric field axis? The axial, okay, electric field due to the axis is equal to 1 by 4 pi epsilon naught. It is 2p vector divided by R cube. And if you consider equatorially, if you consider equatorially, it is equal to 1 by 4 pi epsilon naught, and it is minus p vector divided by R cube. Neglect the directions. So remember, neglect the directions. E axial point is 2 times. Remember, E axial point is 2 times the equatorial. That means the electric field is maximum at any point on the axis compared to the same distance on the equatorial point. So what do you conclude from these two derivations? It's very simple. ಏನು ನಮ್ಗೆ ಅನ್ಸುತ್ತೆ, ಆಕ್ಸಿಯಲ್ ಪಾಯಿಂಟ್ ನೀವು ಯಾವುದಾದ್ರೂ ಒಂದು ಪಾಯಿಂಟ್ ಒಂದು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ನಿಂತ್ಕೊಂಡ್ರೆ ಅದೇ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಈಕ್ವಿಟೋರಿಯಲ್ಗೆ ಹೋದರೆ ಅಲ್ಲಿಗೆ ಹಾಫ್ ಆಫ್ ದಟ್ ಇರುತ್ತೆ. ಆಕ್ಸಿಯಲ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಹೆಚ್ಚಿರುತ್ತೆ, ಈಕ್ವಿಟೋರಿಯಲ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಡಿಮೆ ಇರುತ್ತೆ. ವಾಟ್ ಇಸ್ ದಟ್ ರಿಲೇಷನ್? E axial is equal to 2 times of the equatorial point. One more thing you have to remember, the total charge of the dipole. Second point is very clear. The total charge of the dipole is always equal to 0. What is the meaning? So there are 2 point charges are there, equal plus q and minus q. If you take the sum, what do you get? The total charge of the dipole is equal to 0. So this is the way it is simply we derive the electric field. ಈ ರೀತಿ ನೀವು electric field due to the electric dipole ಎರಡು ಕೇಸಲ್ಲಿ ಒಂದು axial point ಅಲ್ಲಿ ಕಂಡುಹಿಡಿದಿದ್ದೇವೆ, ಇನ್ನೊಂದು equatorial point ಅಲ್ಲಿ ಕಂಡುಹಿಡಿದಿದ್ದೇವೆ. So next we go find generally at any point how to derive the expression for the electric dipole. Okay, for next we are going to derive the electric field due to electric dipole. So electric field due to electric dipole at any point nearer to the electric dipole rather than the equatorial plane or an axial line. So for that, let us consider an electric dipole consists of a plus q charge. This is plus q charge, okay, separated by a distance minus q charge. Let us consider minus q charge. This is center of the dipole. The distance between the dipole is equal to 2a. This is the center. Consider a point P here, so which is at a distance of, okay, we have to draw the distance from point, okay, center to the point P as R. R is the distance, so it makes an angle theta with the dipole axis. The dipole moment is always acting from minus q charge to the plus q charge. Already we know this is what is called as the P vector. So now draw at the point P, we are going to find the electric field due to the dipole. It is neither on the axis nor on the equatorial. For that, let us draw simple, okay, a line perpendicular to the line joining the point P, okay, point P and the center of the dipole. So now look at here, this is the direction. So now we have to resolve the dipole moment. P vector is the dipole moment. So we have to resolve the dipole moment along the line joining the point P as P cos theta. So because of theta adjacent side, so P cos theta. Opposite to that, this is what is called as the P sin theta. So now we resolve the dipole moment P vector into P cos theta and P sin theta. To the point P, P cos theta acts like a dipole along the axis. To the point P, P sin theta acts like the perpendicular. So therefore, we got two dipoles, one along the line joining. Let us consider AB. This is the AB at the point A and point B. At the point A, plus Q charge is here. At the point B, minus Q charge here. So this is the OP. So now this is the direction of the vector. Let us consider E1 vector, that is electric field due to the P cos theta. So that is the axial. We know that what is the E1 vector. So E1 vector is the electric field due to the P cos theta. It is equal to 1 by 4 pi epsilon naught. Remember 1 by 4 pi epsilon naught, it is 2P cos theta. Clear? 2P cos theta divided by into P cap divided by P cap is unit vector divided by R cube. R cube is the distance of the point P from the center. Similarly, the electric field due to P sin theta. P sin theta at the point O, P acts like the equatorial bisector for the dipole P sin theta. So the electric field due to the P sin theta is perpendicular to the E1 and it is acting opposite to the P sin theta vector, that is E2 vector. E2 vector is what? E2 vector is the electric field due to P sin theta dipole. So now E2 is equal to, very clear, E2 is equal to 1 by 4 pi epsilon naught. It is P sin theta divided by R cube into P cap. Remember, both the magnitudes are not same, but they are acting in opposite direction. So if you take the resultant of E1 vector and E2 vector, somewhere in between the resultant vector, E is acting, which makes an angle alpha with the E1 vector. So now we have to find out what is the E vector, that is the resultant of E1 and E2, the net field. Remember, the net field, that is electric field at P is E is equal to, that is E is equal to square root of, that is the resultant of two vectors acting at a point using the parallelogram of law of vector addition. It is equal to E1 square plus E2 square, okay, plus 2 E1 E2 cos theta. Remember, E1 E2 cos theta, but theta is equal to what? Angle between E1 and E2 is equal to 90 degree. Remember, angle between E1 and E2 is equal to 90 degree. Cos of 90 ಏನಾಗುತ್ತೆ? Cos of 90 is equal to 0 ಆಗುತ್ತೆ. So E1 vector ನಂದು electric field due to the P cos theta dipole. This is the dipole. Remember, E2 ಅನ್ನೋದೇನಪ್ಪ, ಇದು P sin theta ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಸೊ ಹಾಗಾಗಿ E1 ಮತ್ತು E2 ನ ನೀವೇನು ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ರಿಸಲ್ಟೆಂಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಫೈನಲಿ ಏನು ಬರುತ್ತೆ? E is equal to E1 ಸ್ಕ್ವಯರ್ ಪ್ಲಸ್ E2 ಸ್ಕ್ವೇರ್ ಮಾತ್ರ ಉಳ್ಕೊಳ್ಳುತ್ತಾ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. E is equal to, so what is that? E1 ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ ಏನಾ? That is 1 by 4 pi epsilon naught 2P cos theta divided by R cube. ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮಾತ್ರ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದಾವೆ. ಇಟ್ ಈಸ್ ಸ್ಕ್ವಯರ್, ಓಕೆ, ಪ್ಲಸ್ 1 by 4 pi epsilon naught P sin theta divided by R square, R cube, remember R cube whole square again. So now take it as common. What are the common terms here? So 1 by 4 pi epsilon naught is common, take outside. P by R cube is also common, take outside. Square and square root cancels, no problem. What is left inside the box? It is 2P. P already we have taken. 2P ತೆಗೆದುಕೊಂಡಿದೆ ಏನು? 2 cos theta whole square ಇದೆ. ಅಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ? 4 cos square theta plus sin square theta. 4 cos square plus sin square theta. So we go for simplification. So therefore E is equal to what is that? 1 by 4 pi epsilon naught P by R cube. So already 4 cos square theta plus sin square theta. Theta already we know what is theta. Theta is the angle made by the line joining the point P with the dipole. So it is clear. So now using 1 cos square theta, 1 sin square theta, what happened? E is equal to 1 by 4 pi epsilon naught P by R cube. So 3 cos square theta plus cos square theta, totally 4 cos square theta plus sin square theta. So what is cos square theta and sin square theta? It is equal to 1. So therefore our final answer expression for electric field is equal to 1 by 4 pi epsilon naught P by r cube into 3 cos square theta plus 1. So my dear students, this is the expression for electric field due to electric dipole at any point. Remember, at any point due to electric dipole rather than neither on the axial point nor on the equatorial point. So this is the formula. So now already we know that what is that? The E vector makes an angle, the resultant vector makes an angle alpha with the, that is direction of, alpha with the direction of what? Direction of the resultant field. So therefore tan alpha, we can find out the tan alpha. What is the tan alpha? Tan alpha is equal to opposite by adjacent. What is the opposite side? Opposite side is equal to E2 vector. Adjacent side is equal to E1 vector. That is E2 divided by E1. What is E2? It is 1 by 4 pi epsilon naught P sin theta divided by what is that? R cube into 1 by 4 pi, that is E1, reciprocal matter in barthe 4 pi epsilon naught divided by 1, it is 2, okay, very good, 2p cos theta divided by r cube agata. R cube, 4 pi epsilon naught, p cancel agata. So therefore tan alpha is equal to half 1 by 2 sin theta by cos theta is equal to tan theta. Therefore alpha is equal to tan inverse of half of tan theta. We know theta is what? Theta is the angle made by the line joining the point P with the dipole axis. So this is what is our definition for the direction, that is expression for the direction of the resultant electric field due to the electric dipole at any point. So this is the magnitude, and this is the direction. Let us consider, if you consider case 1. Sir, if you consider theta is equal to 0, if theta is equal to 0, what happened? The point P is on the axis. If theta is equal to consider, remember, if theta is equal to here, theta is equal to 0 means the point P is on the axis or 180 degree. Again it is point P on the axis only. So now cos of 0 is equal to 1. Cos of 0 is equal to what? 1 agata. Avaga first case electric field enagata. E is equal to, very simple, 1 by 4 pi epsilon naught P by r cube. So ಇಲ್ಲಿ 3 cos square theta ಇದೆ. Cos square theta 1 ಆಗುತ್ತೆ. 3 plus 1 is equal to 4. Square root of that. So it is equal to 4. Okay, square root of the 4 is equal to what? 2. That is E is equal to 1 by 4 pi epsilon naught. It is 2p by r cube. So this is the expression for the electric field due to at any point on the axis. That is the case number 1. Let us go for the case number 2. What is the case number 2? In the second case, put theta is equal to 90 degree. So if you put theta is equal to 90 degree, what happened? So it is in the equatorial bisector. This is what is called as the equatorial bisector, passing through the center. Look at here, passing through the center. So now what happened to that equation? So that is cos of 0 is equal to 1, but cos of 90 degree is equal to what? Cos of 90 degree is equal to 0. So therefore 0 plus 1 is equal to, so this is 3 cos square theta, 0 plus 1 is equal to 1, square root of 1 is equal to 1. So therefore finally what you get? 1 by 4 pi epsilon naught P by r cube only. So this is the formula for calculating the electric field at any point on the axis as well as the equatorial bisector by using the general formula. So how we can find out the electric field expressions at any point, neither on the axis nor on the dipole. So dear students, this is hopefully very important for your board exam, as well as for your competitive exams too. So I hope you enjoy the video tutorial for the electric dipole. We clearly explained about the electric dipole moment, electric field due to the electric dipole at a point on the axis, equatorial bisector, in between anywhere, neither in the equatorial bisector nor in the axial line. That is the expressions. So I hope you enjoy the video. If you like the video, please press the like button. If you have not subscribed yet, press the subscribe button and press the bell button for notifications of the new videos. So for previous videos, watch the link given below, okay, and enjoy the classes. Thank you very much. See you in the next video. Bye bye.